Alright, so equations versus expressions. I'm glad that she brought that part up first because it's important to know when we're dealing with an equation versus an expression. So if I told you all 2x minus 5, what are we looking at here? An expression. Lovely. But if I told you all 2x minus 5 is equal to 11, this one is the equation. Lovely. So always remember equations, those are the guys with the equal sign. That's when you have two statements that are equal to each other. And you can, in this case, solve for x once you simplify it. Now, let's say I wanted to solve for x in this statement. What will I do? Alright. So I heard somebody say we're going to add 5. And then I heard somebody say we're going to take away 5. Which one is it, y'all? Do we add or do we take away? We will add it. Alright? So here's the reason why it's going to be addition, just in case people were confused, because lots of things went haywire with the algebra last term. So, why we add it? Do you all remember back in Form 1 and probably when we initially started the solving equations, we were doing things like writing and seeing an algorithm for the equation and then reversing that process? Yes, I see Shona nodding her head, which is good. For those of us who can't recall that, what I'm talking about is this. Earlier, when we started the algebra, I told you all to get familiar with saying it like this. This statement here is telling me that I am taking a number, I am multiplying it by 2 or doubling it, whichever way you prefer to say it, and then I'm subtracting 5 and the answer is 11, because I was likening it to those mental problems that you all would have done back in primary school where a teacher would say, I think of a number, I double it, I subtract 5 from it, and the answer is 11. What was the number I thought of? That was your initial introduction to algebra, to equations, but you just never had to write equations before. You had to formulate a process to figure out how to get that missing number. Alright? So here we are actually doing the process of finding the missing number, but we're doing it mathematically, where we actually write equations. And the step-by-step process for this can go in multiple ways. But one of the things I've always told you all is that when it comes to an equation, when we think of two things being equal, what do we think about when we think of an equation? Anybody? What was the visual that I gave you of an equation? Think about it. What was that thing last term that I said? When we think of an equation, we think about keeping this thing balanced. What was that thing? A balanced scale. That's it. A balanced scale. So when we think about a balanced scale, we're thinking about making sure that both sides stay the same. They don't tip over to one side more than the other. We want to make sure that the system is always going to be in equilibrium, that it's always balanced. And in this case, if I want to make changes that I can solve for x without tipping my scale to one side, I always have to remember if I do something on one side of my equation, I'm going to do that on the other side of the equation. Alright? And this is where the process of think about the scale now, and you want to remove something from one side of the equation, of the scale, what you'll do in this case, because we have 2x minus 5, I want to get x all by itself. So that means for me to be able to keep the scale balanced, if I'm taking away this 5 from here, right? Well, I shouldn't say taking away, but if I want to remove the minus 5 from here, what I actually have to do is add 5. Alright? And if you all can remember your directed numbers and your identities and inverses from Form 1, you all would know that what this is here is adding the inverse of minus 5, so that way we would get 0. Okay? So this is how we balance it out without tipping the scale. We repeat the same process on both sides of the equation. So here, because this was originally a minus 5, I'm going to add 5 to both sides, and this will now give me, in my next line, I will have 2x is equal to 11 plus 5, which will give me 16. Okay? So always remember, whenever you're doing some sort of change to your equation, what you do on one side, you do on the other. And over here, like I was saying, this minus 5, you want to get rid of it. So to get rid of it, you add 5 to both sides. And that's how we can remove it from this side without tipping the scale over to this side. Alright? From here now, what do we do? We divide 16 by 2. Alright? Essentially, what this summarizes is that you're dividing both sides of the equation by 2. Hence, you will get your answer. And when we divide both sides by 2, what do we get? To 8. There you go, to 8. Alright? So x is equal to 8. Now, like I was saying, the reason why I usually show the little pieces of what I'm adding to both sides, or subtracting from both sides, or dividing both sides by, that is just so that you know what is happening. Because there are some people, they don't know how to, one, show their working, and two, don't know how to solve the equations because they just see like algebra and it just is not making sense to them, and they just kind of randomly put things all over the place, which is something that I saw last term with some of the assessments. Okay, so what to do? Look at your algebraic equation. What do you want to solve for? The unknown. What must you do? Rearrange the equation without tipping the scale over to one side. So what you do on one side, you must do on the other side. Alright? So this was one of those little simple ones, and what I will also do now, I'll rewrite the working without the plus 5 and divide by 2 on both sides, so you'll see what it looks like for people who, you know, could process what they need to do without writing in the steps. So because we have to subtract, we have the subtraction here, right? To subtract 5 here, we add 5 to both sides. So some people, their working might look like this, where they didn't bother to put in the plus 5 both sides. Alright, and then from there we'll get 2x is equal to 16. And then finally, to get x, you divide both sides by 2, and you'll get that 16 over 2 is 8. Alright? There you go. So when you solve for equations, whether you choose to do it with the, as I would refer to, the training wheels, where you show the little steps in between, or you choose to show your working like this, either way you're going to get the correct answer, and you're going to get the same thing. Okay, so it's your choice. You do what is comfortable for you until you can do equations just like this. Alright, so we're going to look at a couple more. We are currently at 12:41, so I have like about, a little under 20 minutes with you all. So we're going to do a couple more equations just to make sure that you will understand how to do the solutions for equations. Alright, so remember, try not to tip the scale over to one side when you're solving. Alright, so let's try this one. Alright, try this one. I'm sure you'll remember seeing some like these last two. Both sides of your equation have algebraic expressions, but that doesn't mean that you can't solve it. All right, it's just going to take a little extra working with your rearranging. All right, so does anybody remember what's the first thing you need to do here? Lovely. Identify your like terms. So anybody wants to tell me where the like terms are at, what the like terms may be? Nice. 3x and the 4x, these guys are like terms. And then that minus 5 with that positive 2, those two are also like terms to each other. Alright, so what do we do from here now? Anybody? We've identified the like terms. What should we do? Alright. So she wants to move them around. Say it. Alright. Good. So, all that. Alright? So, let's do it how she says. She's going to move things around. So, she's bringing this 4x over onto this side. Alright? Now, like I was saying before, if you're doing it the way of balancing the scale, here's a positive 4x. This will translate into subtracting 4x from both sides. So that's how she gets this minus sign thing over here. Alright? That's why this 4x goes from being positive to being negative when it moves to the other side. Alright? And then over here, 2 stays where it is. But negative 5 is moving across to this side. And just like before, in the example before, we had to add 5 to both sides. That's what we're going to do. We technically add in 5 to both sides. And that's where this positive 5 comes out from. Alright? So, everybody has a different way of, recollecting it. Whichever way you are comfortable with, like I just said, comfortable, you do that to suit your needs to make sure that you're comfortable with doing your work. Now, from here, what do we do? Right, and that'll give us. Alright, but remember this is x's, right? There you go, negative x. So negative 1 is understood when you have the negative sign, so you could just write negative x. So negative 1x or negative x, correct. Continue. There we go, we get 7. Alright, what else? Why you want to divide by negative? Why you want to divide negative x by x? Okay. So, you're onto the idea. This is negative x. What do we want to solve for? Do we want to solve for x or negative x? X. We are always trying to solve for the positive variable, not negative of it, but the positive. So if this is negative, right, like we have here, negative x, if I want to get x by itself, just like earlier when we had 2x is equal to 16 and we divided by 2, you can treat negatives in the same manner. Alright? Here, the coefficient is a negative 1. So I will divide both sides by negative 1. And what will I get as my answer? Anybody? What will I get as my answer? See, them directed members just come back and haunt people, Talk to them, anybody? What does this work out to be? We can't leave it just so, Negative 1? Where are we gonna get negative 1? Okay. Let me help you out. So we have negative 1x over negative 1. Alright? So what happens here is that the negative 1 and the negative 1 will cancel out, so it will become a positive x. Alright? And then over here we have a positive number divided by a negative number, don't we? So what is 7 divided by 1? Anybody, what is 7 divided by 1? 7, but this time it's a positive 7 divided by a negative 1. So what should be the answer? There you go, negative 7. Negative 7. I'm going to show you all the other way of doing this as well, because what happens a lot of times, because students end up in a situation where you have a negative x, people get stumped. They either stop right there and think that's the answer, or they just get frustrated because it's like, oh my god, it's a negative x, I do something wrong, and they just write it off completely and don't realize that all they have to do is divide by negative 1 to solve for the variable. Alright, so this is one of the reasons why I always used to encourage my students, when they are solving equations like these, try to make sure that the coefficient of x is going to be positive. That way it makes your process a little bit easier. You don't have to worry about too much negatives. Don't need to stress so much on directed numbers. Alright? So over here, there's another way we can do this, so you don't get this negative x. But at least you see what you can do so that you can solve the equation with the negative x involved. Alright? So once you have this down, this is one way. Now let me show you another way. Alright? So I'll just erase all this. Alright? The like and unlike, well, the like terms, they're basically going to remain the same. Alright? Because we do have two x terms still, and we have two constants still. Alright? So what I'm going to do instead is this. Since my like terms, my 3x and my positive 4x over here, the coefficient of x on this side is larger, right? Because it's 4. Positive 4 is larger than positive 3. I'm going to choose to, quote unquote, bring 3x over on this side instead. So that way I will keep my coefficient of x positive. Alright? So in order for me to be able to bring this 3x over to the right side instead, this is what I'm going to do. I'm going to subtract 3x from both sides of my equation. Alright, just like the balance method I had shown you all earlier with the other equation, we're doing that with this one. So now when I subtract 3x from both sides, this will cancel off with this, and I remain with a negative 5 on the left. Then I have positive 2 plus 4x minus 3x. Now, I have a constant on this side, and I want to put all my like terms on one side. So what I need to do now is subtract 2 from both sides. And this will give me minus 5 minus 2, 4x minus 3x. And all I have to do here is simplify, and I'll be able to solve. Minus 5 minus 2 gives me minus 7. And 4x minus 3x leaves me with just a positive x. And here's something that, happens to a lot of people. They get minus 7 is equal to x, and for some reason don't realize that it translates to mean the same thing, that x is equal to minus 7. So you could just rewrite this as x is equal to minus 7, and you see you get the same exact answer. Okay? Same exact answer. So this is what it looks like to solve the equation using the balance method that I was talking to you all about before. but doing it in such a way that I keep the coefficient of x positive so that I don't have to divide by -1. So again, you work with what is comfortable for you. You don't need to force yourself to use one way only. Alright? Work with whatever is comfortable for you at the instant in time. So this one, you'll see how to do it. Any questions before I give you one more to do before we go? Any questions? No questions. Okay. So let's get one more and we're done. We're done for today. Alright? Okay. Look at this one now. I wonder, will anybody be able to figure this one out? Let's see. So I'll give you like 3 minutes to work on it. Alright? 3 minutes. Okay, so some people said they got 2, some people got 2.5. I wonder, what is the answer? Alright. Anybody else want to tell me what they got before we continue? Oh my goodness. Uh-huh. Uh-huh. Alright, so we have lots of answers. Let's find out which one's correct. So, there are multiple ways in which you could work this one out. And let's see how many ways I could solve this in 3 minutes. Alright? So, the correct answer is 2. Okay? That's the correct answer. So here's how we're going to work this one out. 1, we can apply distributive law. And if you remember your distributive law, you can do 5 by 3m and then 5 by -1. So this will give me 15m minus 5 is equal to 25. And then from there, we do what we've been doing earlier with the balance method. I'm going to add 5 to both sides, and then we'll get 15m is equal to 25 plus 5. And then 15m is equal to 30. And from there, divide both sides by 2. Divide both sides by 15, and that's where we get that 2 from, alright? So m is equal to 2. So that's one way. So very good for the people who got 2. Very, very good as well for those who did it this way. Lovely work if you were able to do your distributive law. Let's go again. Next method. We can start off by dividing both sides by 5, because this is a multiple of 5 and we have that factor of 5 outside of the brackets. So when I divide both sides by 5, I end up getting 3m minus 1 is equal to 5. And then again, it comes back down to that balance method. So I'm going to add 1 to both sides, and I'll get that 3m is equal to 5 plus 1. 3m is equal to 6. And then divide both sides by 3, and we get the same answer, that m is equal to 2. So those are 2 possible ways in which you can get the answer for this question. Alright? So Just saying, for those of us who didn't get 2 as your answer, that's okay. What I would urge you to do is go over things like how we solve equations, go over your distributive law. Make sure that you're familiarizing yourself with all those little things that contribute to algebra, so that way you will not, again, make any little mistakes with doing your solving processes, alright? So you all, it's 1 o'clock. That's it for today.